Hello, this is Mrs. Decker, and in Objective 1D, we're going to be looking at the conversions between moles and molecules. So to do this, you are going to need Avogadro's number, which hopefully you remember from Objective 1A.
So before we move on to today's lesson, I want to do a quick review of yesterday's lesson. So go ahead and pause this video and do the warm-up below. All right, so the first problem is what is the molar mass of KCl? To find the molar mass, you need to add the two masses from the periodic table. So the mass of potassium is 39.10 and the mass of chlorine is 35.45. So you get a molar mass of 74.54 grams per mole. And remember, the units are important. You need to make sure you include your units. So now the second problem says how many moles are in 240 grams of KCl. Our given information is 240 grams of KCl, and we're looking for moles. You do need to find your conversion factor because we're going to use 1 mole is equal to the molar mass of KCl, but we did that already in the problem above. So you start with your given information, which is 240 grams of KCl, and draw your T-chart. So now you're going to use your conversion factor to convert from grams to moles. The grams, molar mass, needs to be on the bottom so that when you divide, grams will cancel out and you put 1 mole of KCl on top. Okay? So you're going to do 240 times 1 divided by 74.54. And you should get 3.22 moles of KCl. All right, so here is Mole Island. In yesterday's lesson, we were focusing on the relationship between moles and mass. Today, we're going to focus on the relationship between moles and molecules. Okay, so molecules can mean the same thing as atoms, particles, or ions. So when you see any of those words, that should let you know that you're going to use the conversion factor of 1 mole equals 6.02 times 10 to the 23rd molecules. All right, here's our first example problem. How many molecules are there in 4 moles of FeF3? So underline your given information, 4 moles of FeF3, and we're looking for molecules. Now our conversion factor between moles and molecules is 1 mole is equal to 6.02 times 10 to the 23rd molecules. Okay, so we're going to use that conversion factor anytime we're converting between moles and molecules. So go ahead and write down your given information and your T-chart. So now you need to, again, make sure that what you're writing on the bottom, the units will cancel out. So we want to write 1 mole on the bottom of FeF3 and 6.02 times 10 to the 23rd molecules of FeF3. And you can go ahead and abbreviate molecules as MC. So now we will do 4 times 6.02 times 10 to the 23rd divided by 1. When we do that, our moles cancels out and we're left with molecules, which is what we want. So the answer you should get is 2.41 times 10 to the 24th molecules of FeF3. Now, in your calculator, you might get the answer 2.41 E24. What that E means is times 10 to the whatever power the number after it is. When you write your answers, I need you to write out times 10 to the 24th. I don't want to see this in your answers. All right, so our next practice problem is how many molecules is 2 moles of beryllium? So again, we're between moles and molecules, so our conversion factor is 1 mole equals 6.02 times 10 to the 23rd molecules. So our given information is 2 moles of beryllium. We're looking for molecules. So write your given information and your T-chart. So again, we want to put moles on the bottom and 6.02 times 10 to the 23rd molecules on top, so that when we do 2 times 6.02 times 10 to the 23rd divided by 1, our moles cancel out. And the answer you should get is 1.20 times 10 to the 24th molecules of BE. All right, the next practice problem says how many moles are in 4.0 times 10 to the 23rd molecules of AgNO3? Our given information is 4.0 times 10 to the 23rd molecules of AgNO3, and we're looking for moles. So again, we're using the same conversion factor, because it does not matter what we're talking about. 1 mole of anything is equal to 6.02 times 10 to the 23rd molecules. So go ahead and write your given information and your T-chart. Okay. So now, in this problem, we want to put 6.02 times 10 to the 23rd molecules on the bottom, and 1 mole on top, because moles is what we are trying to get. So now you're going to do 4.0 times 10 to the 23rd molecules times 1 divided by 6.02 times 10 to the 23rd. So molecules is going to cancel out. It is very important that when you are dividing by scientific notation, that in your calculator you put the whole thing in parentheses. If you do not put the scientific notation you are dividing by in parentheses, the calculator is going to calculate it wrong and you will get the wrong answer. Okay? So if you put this in your calculator correctly, you should get 0.66 moles of AgNO3. All right, and our last practice problem is how many moles is 8.3 times 10 to the 24th molecules of MgO? So underline your given information, 8.3 times 10 to the 24th molecules of MgO, and put a box around moles. And again, we're dealing with moles and molecules, so our conversion factor is the same. So go ahead and write your given information. Okay, and again, since we're given molecules, we want to write molecules on the bottom here. And 1 mole on the top, because moles is what we're looking for. So when we calculate, molecules will cancel out. So you're going to do 8.3 times 10 to the 24th times 1 divided by 6.02 times 10 to the 23rd. And remember, put that scientific notation you're dividing by in parentheses. So you should get 13.79 moles of MgO. So that's your example problems for the conversions between moles and molecules. There are 10 practice problems in your packet. Go ahead and get started working on those and let me know if you need help.